Welcome to the DIY Honda Garage channel. The DTC P04F0 indicates that the Honda Accord's Evaporative Emission Control (EVAP) system has detected an incorrect purge flow. This code signifies that there is an issue with the way fuel vapors are being purged from the EVAP canister, a critical component designed to prevent fuel vapors from escaping into the atmosphere. The EVAP system typically includes several components, such as the EVAP canister, the purge valve, and associated tubing. The canister is usually located near the fuel tank, while the purge valve is often positioned along the engine's intake path. When this code is triggered, it can indicate issues ranging from blockages, disconnections in the hoses, or failure of the purge valve itself. Proper diagnosis and resolution are essential to ensure emissions compliance and optimal engine performance. The DTC P04F0 directly refers to the evaporative emission control system's inability to correctly manage fuel vapor purge flow. The EVAP canister plays a pivotal role by storing fuel vapors captured from the fuel system, thereby preventing them from being released into the atmosphere. The flow of these vapors is regulated by the purge valve that opens under specific engine conditions, allowing vapors to enter the intake for combustion. The proper operation of these components is crucial for compliance with environmental regulations and ensures that the engine runs efficiently without unburned fuel vapors contributing to pollution. The EVAP canister is generally found near the vehicle's fuel tank, while the purge valve is strategically located between the canister and the engine's intake system, leading to various potential failure points, including blockages or leaks in related hoses. To accurately troubleshoot DTC P04F0, it's critical to consider potential causes that could contribute to this error. One common issue is poor connections or loose terminals at critical points, such as for the EVAP canister, purge valve, and the powertrain control module, PCM, which could interrupt proper signaling or functionality. Additionally, blockages can occur in the purge tubing, obstructing the vapor flow necessary for normal operation. A damaged purge valve may fail to open or close correctly, resulting in incorrect purge flow. The intercooler outlet can also accumulate debris or become clogged, further affecting vapor flow. Lastly, a malfunctioning EVAP canister that has internally collapsed or degraded can fail to store vapors as intended, contributing to the DTC being triggered. When DTC P04F0 is present, the driver may notice several symptoms that indicate a malfunction within the EVAP system. Firstly, the check engine light will likely illuminate, prompting immediate attention for diagnostic evaluation. Additionally, the vehicle may experience decreased fuel economy due to inefficient vapor management, leading to richer fuel mixtures and wasted fuel. A failed emissions test is a common consequence that can arise from this fault, as an improper purge flow can lead to excessive emissions, violating regulatory standards. Drivers might also encounter a noticeable gasoline vapor smell, particularly near the fuel tank area, suggesting a leakage issue within the EVAP system. As a result of these issues, engine performance may stutter or lag under certain conditions, making it imperative to address the DTC promptly. In the first troubleshooting step for DTC P04F0, begin by turning the vehicle ignition to the on mode, which powers up the vehicle's electrical system without starting the engine. Next, you'll need to clear the diagnostic trouble code, DTC, using the Honda Diagnostic System, HDS, a tool designed for troubleshooting and diagnostics in Honda vehicles. Once the DTC is cleared, it is essential to conduct a functional test of the EVAP system through the HDS by selecting the EVAP test option. After the test, check if DTC P04F0 is re-indicated. If it does reappear, this signifies that the initial issue is still present, confirming that you have duplicated the failure. If not, it may be an intermittent failure, hinting at potential loose connections or faulty terminals that need further inspection. For the second troubleshooting step, begin by turning the vehicle to the off position, ensuring all electrical systems are shut down. This is crucial as you will need to perform a thorough visual inspection of Purge Tube B, which is the line connecting the EVAP canister purge nozzle to the purge valve. Inspect this hose carefully for any signs of poor connections, blockage from debris, or physical damage that could impede vapor flow. Confirming the integrity of this line is essential, as any defect here could lead to the triggering of the DTC. If the hose is found to be in good condition, you can advance to the next step in the troubleshooting process. If there are issues detected, make the necessary repairs or reconnections before continuing. Step 3 involves checking Purge Tube D, which connects the EVAP canister purge nozzle to the throttle body inlet pipe. Begin this step by visually inspecting the connections and overall integrity of the hose to ensure there are no blockages or physical damage. The thorough inspection of this line is crucial, as blockages can lead to an incorrect purge flow, contributing to the P04F0 code being triggered. If the line is in acceptable condition, you can proceed to the next troubleshooting step. However, should you discover any issues, make sure to disconnect and replace or reconnect Purge Tube D to ensure a proper seal and flow before advancing in the diagnosis. In this fourth troubleshooting phase, you will need to remove the EVAP canister purge valve while keeping the connector and vacuum hose attached. After accessing the valve, you must proceed to disconnect the vacuum hose from the purge valve, as well as the purge line from the EVAP canister. This step allows you to connect a T-fitting, vacuum gauge, and vacuum pump directly to the EVAP canister purge line to assess its integrity. Carefully apply a vacuum of about 2 kilopascal, equivalent to approximately 0.6 inch reg. This is a critical moment where you need to determine if the line holds the vacuum. If it does, this points towards a potential blockage within the EVAP canister purge line itself that needs further inspection. If it does not hold vacuum, then further troubleshooting is necessary to identify additional issues within the system. The fifth troubleshooting step involves focusing on Purge Tube D again, particularly its connection to the intercooler outlet pipe. Begin by disconnecting Purge Tube D from the intercooler outlet pipe to facilitate the inspection. At this point, connect the vacuum pump and gauge to the tube to prepare for a vacuum test. Like previous steps, apply vacuum to this hose and observe if it can maintain that vacuum. If the tube holds the vacuum correctly, the issue is likely not at this section of the system. If it fails to hold vacuum, it indicates a blockage, requiring further inspection of the run from the intercooler to the EVAP canister purge nozzle. In step 6, you will need to carefully inspect the port at intercooler outlet pipe B. This part is integral as it connects to the Purge Tube D, and any debris or clogging here could severely impact the ability of vapors to flow as intended. Using appropriate tools, assess the port for any blockages or particles that could be obstructing the path. If debris is discovered, it should be cleaned out thoroughly. If the port is significantly damaged or clogged, you may need to consider replacing the intercooler outlet pipe to ensure unimpeded flow and restore proper functionality to the EVAP system. Moving on to the 7th step, disconnect Purge Tube B from the EVAP canister purge nozzle, allowing you to connect the vacuum pump and gauge directly to this hose. This connection enables a test that will help assess the integrity of this specific section of the evaporative system. Utilize the HDS to select the EVAP test option and subsequently opt for the PCS CPV on setting. which activates the purge solenoid for testing purposes. Upon applying vacuum to tube B, it is crucial to monitor whether the vacuum is maintained. If it does hold steady, this indicates a clear flow path through the line, and you should investigate the previous sections for potential issues. If the vacuum fails to hold, Step 8 becomes necessary for further diagnosis. For the final troubleshooting phase, you will need to inspect non-return valve B. This valve is a critical component that allows vapors to flow in one direction while preventing backflow, which is essential for the proper function of the EVAP system. Carefully examine the valve for any signs of obstruction, debris, or damage that could hinder its operation. A blockage could lead to incorrect purge flow, ultimately triggering the P04F0 code. If the valve appears compromised, it will need to be replaced to restore proper functionality. If the non-return valve checks out, then inspect the EVAP canister purge nozzle port for any collected debris, as that could also contribute to the symptoms observed. Once all troubleshooting steps have been executed and any necessary repairs made, it is crucial to perform a thorough final repair verification. Begin by ensuring all components and connections are properly reassembled and secure to prevent future malfunctions. Next, conduct a final EVAP test using the HDS to confirm that the system is operating correctly without triggering the DTC P04F0. Once you verify that the DTC has been cleared, a test drive of the vehicle is warranted to confirm that all systems are functioning as intended under normal driving conditions. Monitoring the check engine light during the test drive will help validate the repair's success. Ensure that there are no persistent symptoms and that the vehicle runs smoothly. To prevent issues related to DTC P04F0 from arising in the future, regular preventive maintenance is essential. One important practice is to routinely inspect all EVAP system components, including connections and hoses, to ensure they are clean and properly sealed. Keeping these areas in good condition can significantly minimize the risk of blockages or leaks that would lead to error codes. Additionally, adhering to a scheduled fuel filter replacement can help ensure that contaminants do not obstruct fuel systems or cause issues in the EVAP system. Furthermore, always using high-quality fuel can prevent sediment buildup in the fuel system, which can affect evaporative components adversely. Committing to these maintenance practices will enhance system longevity and vehicle reliability. In conclusion, DTC P04F0 specifically indicates an issue with the evaporative emission control system's purge flow, often tied to several core components such as the EVAP canister, purge valve, and associated tubing. Effective troubleshooting involves a systematic approach, starting from verifying the DTC, conducting visual inspections, and testing for blockages in relevant lines and valves. Each step taken can lead to identifying and fixing the root issue, ensuring that the DTC is cleared and the vehicle operates efficiently. Furthermore, regular preventive maintenance plays a crucial role in maintaining the integrity of the EVAP system and preventing future occurrences of similar issues. Always adhere to the diagnostic procedures and verify repairs through thorough testing for optimal vehicle performance and compliance with emission standards. Please like and subscribe to the channel. See you next time!